In most of the videos this week, we'll be talking about entire curves in terms of their individual segments. Really, we think of a curve that goes through a lot of points most of the time as a bunch of little curves that each go through a pair of points but get joined up smoothly. So for example, suppose we wanted to draw a curve through these 6 points. We might be looking for this curve. And so we say, all right, this is the curve we want to draw. When we think about creating this in processing, there is indeed a shortcut where we can basically hand it these 6 points and it simply draws this curve. If all we want to do is draw the curve, that's fine. But there are a lot of other things that we can do with this curve. We can move an object along the curve. We can draw curves that are to one side or the other of this curve. Those techniques and others all rely on thinking of the curve in terms of its individual segments. So it's just as if we were to draw the curve using straight lines, but of course we don't use straight lines. So instead of drawing a straight line from 1 to 2, we draw a curve segment. Then from 2 to 3, we draw another segment, and so forth. Each pair of points is joined up with a segment. The big trick to drawing curves and processing is to get the segments to join up smoothly at each of these points, because really each of these segments is completely unrelated to all the others. They only join up smoothly because we can be careful when we create them and we can make them smooth. And we'll talk quite a bit about how to make smooth curves. So that's the basic idea. We want to think about big curves in terms of their individual segments and how to join the segments together to make them smooth. As I said in the overview, there are 2 kinds of curves we're going to look at this week. The first is the Catmull-Ram curve. To draw a single segment of a Catmull-Ram curve, we hand processing 4 points. Here I've labeled the points A, B, C, D. If we hand those 4 points to processing in order, A, B, C, and D, it will draw the curve segment between B and C. Points A and D are important because they help shape the curve, but they don't participate in the drawing process. The other type of curve is called the Bezier curve. It also takes 4 points in order. Here again, I've named them A, B, C, and D, but the difference is that the curve is drawn between the first and the last points, here A and D. And the middle 2 points, here B and C, are used for shaping the curve. These are relatively small distinctions, but it turns out that they have a huge effect in terms of how easy it is to draw the curves and how much control we have over them. In general, each Catmull-Ram curve is easier to draw, and it's easier to get them to line up smoothly. The Bezier curves take a little bit more work, and getting them to join up smoothly is a little bit more difficult, but they offer us much more control over the shape of the curve that gets drawn. Let me show you an example. We'll start first with Catmull-Ram curves. So suppose that we want to draw a curve through these 5 points, working our way generally left to right. For reasons we'll get into later, I'll add an extra point at the beginning and the end to help shape the curve. So we're going to draw Catmull-Ram curves. We grab the first 4 points, hand it off to processing, and it draws a little arc between the middle 2 points. Now we hand it the next 4 points, and it draws a little curve. Then we hand it the next 4 points, and so on, working our way through the curve. Finally, we hand it the last set of 4, we draw that little arc, and if we back off a little bit, we can see that the result is one smooth curve that passes through all the points. Now, we had very little control over the shape of this curve. We just handed processing batches of 4 points, and it drew curve segments between the middle 2. The shape of each segment was determined by the 4 points that defined it. Let's start over again with the same set of points, but this time we'll draw Bezier curves. Well, the Bezier curves let us move these 2 middle points here that I've drawn with open circles, and we can really put them almost anywhere we want. So if I put them up here like this, we get this curve. Now we say, okay, we've drawn that segment. Now we want to draw the next segment. Well, suppose that I put those little open circles in these wild positions. The segment that processing will draw in response to this is that little S shape. So that's really cool. We have much more control. We can do really wild things. For the next pair, let's draw the lines that go out to the open circles in this big X formation. The curve that processing draws in response to these 4 points is this. It actually has a loop in it. And then finally, we'll wrap things up. I'll pick 2 open circles that are very far away, and we get this nice sort of backward C shape. Let's recap and get the general picture. If we go through the points with a Catmull-Rom curve, then we don't really have a lot of control over the shape of the curve, but it's very easy because we just hand the points on the curve to processing. If we draw our curve segments using a Bezier curve, we have much more control over the little curves that get drawn, but they still go through all of the points. And indeed, these 2 curves do go through the same 5 points, but they look wildly different. So that's the general idea this week. Most of the time, we're going to think about curves in terms of the individual segments. We're going to build our curves up one little piece at a time. There are convenience methods, particularly for the Catmull-Rom curve, that let us draw the whole thing at one go, if all we want to do is draw the curve, and that's great. For the times when we want to do other things with the curves, like use them as a path to move an object, or to draw other curves to one side or the other, then we talk about those things in terms of each of the individual segments. Both kind of curves are really useful, and you'll find yourself using both varieties all the time.